Okay, in space diversity, we have two main types: the receiver diversity, meaning that we have multiple antennas at the receiver, and the transmitter diversity, meaning that we have multiple transmitters or antennas at the transmitter. Okay, so the receiver diversity is more popular. Okay, the transmitter is not as much as popular. So if we have both of them, meaning if we have multiple antennas at the transmitter and multiple antennas at the receiver, this is called multiple input, multiple output system, a MIMO or a MIMO system, depending on your accent. This is what is used currently in the 4G and 5G systems. So the main point of diversity is to improve the performance. Mainly, we want to improve the SNR, which will improve the bit error rate ultimately. Okay, so in order to do that, we need to determine the SNR and then the probability distribution, so we can ultimately reduce the outage probability and improve the SNR to get better bit error rate performance. So in our lecture, in our setting, we will just discuss the Rayleigh fading because it's a simple type of fading and we can do so much with it. As we said earlier, if we have Rayleigh fading, then the power is exponentially distributed, where gamma bar is the average SNR. So what we do here is that since we have multiple antennas, we will get multiple SNRs and we will discuss how to combine them in some way. And we hope that the resulting SNR is better than or at least equal to the best SNR that we get here, right? So we use this combined SNR to improve the outage probability. Remember, the outage probability is the probability that the output combined SNR is less than the minimum required SNR, or as we used to call it before, it's the receiver sensitivity, meaning that the receiver will not hear the transmitter, so to speak. So this is a simplified figure of the space diversity. Like I said earlier, we have multiple receivers, so we have gamma 1, gamma 2, and gamma n. So we need to combine those SNRs in a way to improve the output or the ultimate SNR. So we have different types of receiver diversity. We will discuss them in detail. So the first one is called selection combining, meaning that since we have multiple antennas, multiple received SNR, we'll select the best one, right? Threshold combining, it's an improvement on the selection combining. The best one is the maximal ratio combining or MRC. This will give us the best performance, but of course this good performance comes at an increased cost of complexity regarding the receiver. Finally, we will discuss the equal gain combining, which is a simplification of the MRC.